In electronics, it is quite common to find very large and very small numbers. For example, a resistor might have value 2,500,000 ohms, or a capacitor might have value 0.000047 farad. I'm sure you would agree that it is inconvenient to have to write all these zeros. Furthermore, it is quite easy to make a mistake when keeping track of all those zeros. Therefore, we often prefer to use scientific notation instead of ordinary notation. So, for example, the number 2,500,000 can be written in this way. We write the non-zero digits as a number between 1 and 10, in this case 2.5, and then we scale the number appropriately using a power of 10. In this case it's 10 to the 6th. And this symbol you see after the scientific notation just refers to the units which we're measuring, in this case the ohms for resistance. For the small number, the 0.000047 farad, again we write the non-zero digits as a number between 1 and 10, so we write 4.7, and then the scale factor in this case is 10 to the negative 5. The negative exponent tells us we're dealing with a small number. Okay, so let's go over the rules that we have for converting to scientific notation. Okay, so first we write the non-zero digits as a number between 1 and 10, as I said. And then we need to multiply by the scale factor. And in order to determine this exponent, we simply have to count the number of places we need to move in order to move the decimal point from its original location, in this case here, to the new location, which would be here. So how many places do we have to move? 1, 2, 3, 4, 5, 6 places. So that's where we come up with this 6. Okay, so if we're moving the decimal point to the left, as we did in this example, then the exponent is positive. But if we move the decimal point to the right, as we do in this example, then the exponent will be negative. But it's the same rule, 1, 2, 3, 4, 5 places. That gives us this 5 here, but the exponent is negative to give us the small scale factor. Now, a modification on the scientific notation is so-called engineering notation, where we only use powers of 10 that are divisible by 3. In other words, the exponent is divisible by 3. So we have 3, 6, 9, 12. Okay, so for example, we need to write 56,000 in engineering notation. Okay, so since we're dealing with thousands, we want a scale factor of 10 to the third. So that means we need to move the decimal point 3 places, 1, 2, 3, and the answer is 56 times 10 to the third. Okay, next example we have 0.408 in engineering notation. This time the scale factor we're going to use is 10 to the negative 3. So we have 1, 2, 3, and the answer is 408 times 10 to the negative 3. Okay, this one's a little harder. We have 1.62 times 10 to the fourth in engineering notation. Now 10 to the fourth is 10,000. So if we want to have a scale factor of 10 to the third, that means we need to move the decimal point 1 place to the right. and we get 16.2 times 10 to the third.